Say, Bob, where did you get that pump? It doesn't look like any of those I've seen you working on before.
This is one of those new roller-type pumps, Joe. A few of them were used on 1968 cars, and I understand a lot more of them will be used on this year's cars.
This new pump has a lot of good design features, Joe. Besides, it's an easy pump to service, and more service parts are available for rebuilding it than most of the pumps we've used on our cars.
Do you suppose you two could take time to fill me in on this pump? I like to keep up on any new stuff that comes along.
Oh, I guess we can spare a little time for a young fella that's eager to learn. How about it, Bob?
Sure thing, Tech. As a matter of fact, I finally figured out exactly how this pump with its combination flow and pressure relief valve works myself. Tech can check up on me to see if I have everything figured out right. To begin with, this new pump gets its name from the 12 steel rollers that fit into V grooves in the rotor. These rollers replace the slippers or vanes used in the other type pumps. The rotor is driven by the pump pulley, and the rotor and rollers rotate inside an elliptical cam ring. When the pump is operating, centrifugal force moves the rollers outward against the cam. Now notice, this pump has two pump inlets. The two inlets are opposite each other, where there is a lot of room for incoming fluid in the space between the roller, the V groove, and the cam ring. This is where the intake or low pressure ports are located. There are also two outlet or discharge ports. At these outlet pressure points, the cam ring pushes the rollers into their V grooves. The rollers literally squeeze the pump fluid out of the V grooves and into the pump discharge ports.
Since the two pressure chambers are directly opposite each other, they balance out the radial loads on the rotor. As a result, there are no hydraulic side loads on the pump shaft and bearings.
It sounds like this should be a real good pump, but tell me, is there something special I ought to know about servicing it?
The servicing instructions in the manual are complete and easy enough to follow. However, there are a few precautions that are especially important. For instance, be sure and use this special puller to remove the pump drive pulley. It'll make the job easier, and you won't damage the pump or the pulley. Pump disassembly is simple if you know how to go about it. Remove the reservoir and clamp the pump body in a vise with soft jaws, pump shaft down. This will make it easy to get at the end cover retaining ring. Here's the trick in getting the ring out of its groove. Tap the end cover retaining ring around in its groove until one of its ends is opposite the small hole in the pump body. Use a pin punch to push the end of the ring out of its groove, and the rest is easy.
A couple of changes were made in the pump after the 1969 service manuals went to press, so we'll pass on the latest pump assembly tips and precautions. You'll find it easier to assemble a pump if you put the dowel pin in first, followed by the seal plate gasket and the seal plate. Make sure the cutout sections of the gasket and plate face the intake ports in the pump body. You'll find the latest information on servicing early production pumps with round seal plates in the reference book. When you assemble a thrust plate, make sure it goes into the bore chamfered edge first. And of course, the index notch of the plate must line up with the dowel. The machine notch in the cam ring must go up. Some cam rings have only the machine notch. Others have a formed notch in one face and a machine notch in the opposite face. After the rotor and rollers are positioned in the cam ring, lubricate them with power steering fluid. Then spin the shaft to position the rollers properly. If the rollers were cocked, they would interfere with the assembly of the pressure plate. Before you install the pressure plate, make sure the end of the dowel pin is 3/16 of an inch above the cam plate. Line up the index notch with the dowel pin. As a final check, look through the pressure ports. You must be able to see all 6 holes in the cam ring, 3 through each port opening.
Be sure and seat the pressure plate against the cam ring. If there's any excess clearance between the cam ring and the pressure plate, the pump won't develop pressure because it won't be able to prime itself. With this new pump, you don't dare press the pulley onto the shaft, or you'll push the pressure plate away from the cam ring. If that happens, the end cover spring isn't strong enough to reseat the pressure plate, and the pump won't prime.
Even a good bump on the end of the shaft will unseat the pressure plate. That's why it's so important to use the special pulley installing tool. You'll find all of the service details in your service manual, so be sure and use it.
Well, tell me, Tech, which pump parts are serviced?
In addition to the partial pump assembly, which includes everything except the reservoir and pulley, There's a sealed package and a rotating parts package. And now let's talk about our new two-stage flow valve. Some of our competitors get by with a single-stage flow valve, but a two-stage flow valve is a good feature, and here's why. At low engine speeds, particularly when parking, the power steering pump must provide high flow so that gear demand won't be greater than pump output. At highway speeds, the flow from this same pump would go sky high at the very time when the flow demand of the gear was low.
Why is that bad?
Excess flow heats up the fluid and wastes power. A two-stage flow control valve provides ample flow for full assist at low engine speed and then reduces flow to the amount needed at higher speeds.
Well, just how does a two-stage flow control valve work?
This cross-section helps explain it, Joe. At low engine speed, the entire flow from the pump goes from the pump pressure chamber to the pump outlet and is supplied to the steering gear. That's because the pump bypass is closed off by the flow control valve. Now notice, there's an orifice in the passage leading directly from the pump pressure chamber to the pump outlet. You'll also notice that there's a second orifice and flow path that leads into the spool valve bore and then to the pump outlet. Also, if you look real close, you'll see that there's a small passage through one end of the spool valve. This is a pressure sensing port for the chamber at the spring end of the spool valve. Are you still with me?
So far, so good, Bob.
As pump speed and flow increases, pressure builds up at the plug end of the valve. However, there's a pressure drop at the two orifices. Because of the sensing port, there is also a pressure drop at the spring end of the valve. As soon as the pressure difference between the two ends of the valve is great enough to overcome the spool valve spring, the spool valve moves far enough to uncover part of the bypass passage. Flow is reduced because part of the pump output is returned to the pump inlet. At still higher speeds and lower gear demand, the pressure difference moves the valve even more. One flow path to the pump outlet is blocked completely. The additional pressure drop at the spring end of the valve causes it to move even more, uncovering more of the bypass. With the valve in this position, most of the pump output is returned to the pump inlet. Only the flow required for normal highway driving is supplied to the gear. There is no waste of power or unnecessary heating of the fluid.
Where's the pressure relief valve for this pump?
It's hidden right inside the flow valve, Joe. It's actually a triggering device that causes the flow valve to limit pressure. Here's how that works. A spring-loaded, ball-type pressure relief valve in the spring end of the flow valve is normally closed. As long as the pump pressure doesn't exceed its rating, the pressure relief valve doesn't affect flow valve operation in any way. However, suppose the front wheels are turned hard over against their stops. When pressure builds up to rated maximum at the spring end of the flow control valve, it unseats the relief ball and fluid is dumped into the bypass passage. When this happens, there is flow through the sensing port in the spool valve. When the relief ball pops open and there is flow to the spring end of the valve, the sensing port becomes a pressure controlling orifice. The pressure drop across this orifice determines valve position necessary to maintain rated pump pressure. This setup is called a trigger-type relief valve. Unseating the relief ball doesn't provide enough flow to relieve pressure. Instead, the pressure drop across the trigger orifice makes the flow valve double as a pressure control valve.
The complete flow valve assembly is selectively fit to its bore in the pump housing. For that reason, the valve isn't serviced separately, and the flow valve from one pump must not be used in another pump. The valve can be removed and cleaned, but the separate parts are not serviced. Shims are used to determine the pressure rating of the pump. When you clean a valve, save the shims so they can be reassembled after the valve has been cleaned. Do not change the number of shims.
This new pump is supplied in 3 different pressure ratings, depending on car model application. If you replace a pump, be sure and get the correct part number. And now, if you turn the record, you'll be able to hear what we're going to tell Joe about power steering gears.